Hello students. So today discussion is about the chapter structure of atom. So this chapter is very important. Why? Because this chapter deals about atoms, subatomic particles, their discoveries and atomic models, electronic configuration, the key concept in chemistry, students. So let us start the discussion. First of all, the idea of atom is given by many old Indian philosophers, Greek philosophers, from other parts of the different worlds. They already have said about an atom. So even our Indian philosopher Maharishi Kannad, he said that the whole universe is made up of Anu and Paramanu. So but theoretically given, so not all like all the regular points, but the English chemist John Dalton, so he gave certain points, certain postulates about the atom, and that is called as Dalton's atomic theory. But first of all, what is an atom? How does this term atom arises? Atom is a Greek word, Greek word, students. Atom in Greek, atomos in Greek, which means indivisible or uncuttable, That means if you break any matter into two parts, break down the matter into two parts and again break it down into another two parts, ultimately you will get a particle which you cannot divide into furthermore. That particle is called as an atom. So indivisible particle, the ultimate particle, is called as atomio, which in English we are calling it as an atom. Understood? So whether it is indivisible or not, everything we'll discuss in this video, in this chapter. So in English, scientist John Dalton proposed that the matter is made up of very small indivisible particles called as atoms, meaning indivisible particles. What is the meaning of indivisible? That is ultimate particle the whole matter is made up of. Now not everything. Atom is the ultimate particle. So next, so look at some of the points given by Dalton's in his Dalton's atomic theory, students. So first, matter consists of small indivisible particles called as atoms. The very first point, all matter. What is matter? Anything which has mass and occupies space. Everything is matter. We are also part of matter, yes or no? So all the matter is made up of indivisible particles called as atoms. Is this point correct or not? Whether it is correct or not, in the coming slide we'll discuss, right? Next, atoms can neither be created nor be destroyed. That means we cannot create an atom. Even we cannot destroy an atom. Don't think, sir, we are burning and destroying. No, it is simply converting from one form to the another form. That's it. Sir, an apple is, a flower is blooming, an apple is getting produced, a fruit. So it is new matter is no. The nutrients converted into that source. That's it. Understood? Matter can change from one form to the another form, but we cannot create matter. We cannot destroy matter, according to the John Dalton. Atoms of same elements are similar in all the respects. Conversely, atoms of different elements are different in all the respects. That means same atoms, for example, hydrogen atom. Are these two atoms same or different? Same, that's what he's saying. Hydrogen atom, helium atom. Are these two atoms same or different? Different, that's what the point says. Atoms of same elements are all same in all respects. Respects means mass, electron charge, proton charge, number of subatomic particles, everything. Reactivities, physical state, all are same. Atoms of different elements are different in all the respects. Okay, this point is valid or not, we'll see in the coming slide. Atoms combine in small whole number to form the compounds. Atoms today are called as molecules. So for example, H2O, small group of atoms are combined or not? 2 hydrogens and 1 oxygen. Carbon dioxide, CO2, 1 carbon and 2 oxygen. So atoms are combining in these small whole number ratios and they form compound atoms. He called it as a compound atoms. Now we are calling them as molecules. Yes, our students, right? Next, atom is the smallest unit of matter that takes part in a chemical reaction. So whatever the chemical reactions happening, the smallest, the ultimate particle which is participating is atom. So these are the points given by John Dalton, students, but all the points, almost all the points are proven wrong. Why? How? See. Defects of Dalton's atomic theory. Why? At that time all the points are correct, but what makes these points proven wrong? First of all, first point, atoms can be divided further into subatomic particles like electrons, protons and neutrons. Yes, sir, what he said? Atom is the ultimate particle, atom is the indivisible particle. Yes, sir, no, but students don't think indivisible means cutting, breaking, not like that. He said it is not made up of anything, that's the ultimate particle. But what do we know after the later on studies? What do they prove? Atoms are still made up of 3 subatomic particles called as electrons, protons and neutrons. Yes or no? That means the point given by the Daltons is proven wrong or not? Next. Students, next one is nuclear reactions show that atoms can be created or destroyed. Yes, what the point given by Dalton? We cannot create atom, we cannot destroy atom. But students, of course, not by normal chemical reactions we cannot do, but with nuclear reactions we can create new elements. We can destroy existing elements also. Yes or no? Nuclear reactions means reactions takes place with nucleus. That means two types of nuclear reactions are there: nuclear fission reactions, nuclear fusion reactions. Fission means one element break down to simpler elements. Fusion means simpler elements combine to form one big element. That means we can create new atoms or not, students? That is what. So this point also proven wrong. Discovery of isotopes proves that atoms of same elements needed to be similar in all the respect. What are isotopes? We'll discuss in the coming slides of coming videos or in this chapter. So first of all, I'll give the clarity. Discovery of isotopes proves that atoms of same element need not to be similar in all the respects. What he said? Atoms of same elements are all same. Everything is, sir, no. Hydrogen atom, same in all the respects. But that is not same in all the respects. When isotopes means, students, atoms of same element only, but sometimes some atoms have different number of neutrons are present. You already know atoms are made up of 3 subatomic particles: electrons, protons, neutrons. Hydrogen contains 1 proton, 1 electron, yes or no? But don't think all the atoms of hydrogen in the universe contains 1 proton, 1 electron only. Some atoms contains 1 neutron. Some hydrogen atoms contains 2 neutrons. If neutron number is changing, neutron particle is the particle which provides mass. Definitely mass also changes or not, students? Hydrogen atom only, proton is 1. This hydrogen atom also 1 proton only. But this hydrogen atom, it doesn't have any neutrons, no neutrons, and this hydrogen atom contains 1 neutron. There is a difference or not? Difference in what? Difference in mass. They're called as isotopes. In detail, we'll discuss in the coming video. So this is proven wrong. So atoms of same element also can be different based on the difference in their number of neutrons, subatomic particles. Next, discovery of isobars proves that atoms of different elements need not to be different in all the respects. Isobars. Isotopes means what happens, students? Same element but different masses. Isobars means same masses but different elements. Yes, correct. So mainly the mass of an atom is coming from protons and neutrons only, students. Protons and neutrons only. So if an atom contains same number of proton neutron count number and different element also contains same proton neutron count, then they have same masses or no? Different elements only. Different proton. Because of neutrons, their mass numbers are same. Different elements can have same masses also. Carbon 14, nitrogen 14. Carbon is a different element, nitrogen is a different element, but they can have same. They are called as isobars. So different elements need not to be different in all the respects. Yes, sir. They have same masses, which is not given by Dalton. Next, discovery of polymers and macromolecules proves that atoms can combine in large molecules. What he said? He said atoms always combine in a simple whole number ratio. No, atoms can combine by large number, not only simple, by large number of molecules also. They can form a long chain molecules also. Best example, synthetic fibers, natural fibers. Yes or no? They have plastic polymers. So they have all bigger molecules or not? So all these points proves the Dalton's atomic theory wrong. So sir, if the atom is divisible, then still why we are calling it as an atom? The meaning is indivisible. They already have given that name. We followed for so long time and the name remains. That's it. Nothing to change with that. But we already know the concept, right, students? Atoms are still made up of 3 subatomic particles. What are the particles? Electrons, protons and neutrons, right? So first, discovery of electrons. Discovery of electrons. This is done by the scientist J.J. Thomson, students. The discovery of electron done by the scientist J.J. Thomson. This experiment is called as cathode ray tube experiment or discharge tube experiment also. Both are same. Simple experiment. I'll explain clearly. Listen, guys. There is a glass tube, cylindrical glass tube, right? Correct. Closed glass tube. It contains 2 electrodes which are connected to the electricity source, high voltage electricity source. And in these 2 electrodes, one acts like a cathode, one acts like an anode. Cathode is a negative charge electrode, anode is a positive charge electrode. And by taking some of the gas, like any hydrogen gas or helium gas, inside the glass tube, and there is a vacuum pump. I'll explain what is vacuum pump, and at a low pressure conditions. Why low pressure also I'll explain. And you can see some green glue is mentioned here. Why? Because a special material is coated here. The material is called as phosphorescence material. The formula is ZNS, zinc sulfide. So under all these conditions, students, once if he initiate the experiment, what is the experiment? Two electrodes connected to the high voltage source by maintaining low pressure, by coating phosphorescence on the backside of anode. Inside the glass tube there is a gas, hydrogen gas or helium gas. Once if he initiated the experiment, he observed some rays, you can see the arrows, are moving from the direction of cathode to the direction of anode. These rays are called as cathode rays. These rays are called as, students, cathode rays. So now let us discuss all the main points in this experiment. Students, first of all, why high voltage? What is the gas which is taken inside the glass tube? Let us take hydrogen gas. Yes or no? Hydrogen gas is made up of how many atoms, students? 2 hydrogen atoms, right? Yes or no? Atoms contains electrons and protons, right? Hydrogen contains 1 electron, 1 proton. Yes or no? What Thomson is discovering? Electron. Where the electrons are present? Inside the atom. We need to remove the electron or not? Yes or no? That's why high voltage condition is maintained. Once if this temperature is maintained, if this condition of high voltage is maintained, electrons inside the atom, they will knocked out of the atom. That's why high voltage condition is maintained. Sir, why to knock out? He is discovering electrons, right? That's why he maintained. Sir, how does he know? That is the research. Understood, students? So he maintained high voltage condition simply to knock out the electrons. Remember, once electrons were knocked out, hydrogen atom contains a proton and an electron. Once electron was knocked out, what is the remaining particle, students? Once electron was knocked out, the remaining particle is proton and electron independently. Are they combined? If they combine, they form a neutral atom. Electrons were knocked out, yes or no? So inside the whole glass tube, now we left with protons and electrons separately. Why? Because we already separated electrons, right? Now, low pressure condition, students, low pressure condition means if high pressure is there, what will happen? These electrons and the protons again they combine and they form hydrogen atom. Do we need that? Do we need hydrogen atoms in this experiment? No. What he is discovering? Electrons. Definitely we need to stop this combination or not? They need not to be combined. Sir, why they are combining? Why? Because protons are positive charge, electrons are negative charge, attract with each other, they will combine at high pressure conditions. Yes or no? Do we want that combination? No. We want to stop that combination. So that we have to maintain low pressure condition. Sir, how to maintain the low pressure condition? Simply, if we can maintain less number of particles, low pressure. How can we remove some of the particle? Using this vacuum pump. That's why the use of vacuum pump. We can remove some of the gas so that there are very less number of particles. If there are very less number of particles, the distance between the particles will be more or not? They can easily collide? No. Understood? That's why low pressure condition is maintained. Under these conditions, now these particles are moving towards anode. Sir, why this phosphorescence? Phosphorescence means, students, when any charged particle, when any energetic particle strikes on its surface, it glows. It gives a glow. For example, radium balls, of course, it's a different phenomenon. What will happen? If you focus a light energy, it will give a glow, yes or no? It works on the same principle. If any charged particle strikes on the surface of phosphorescence, it gives a spark, right? That nature is that phosphorescence is not phosphorus. Phosphorescence is glowing nature is called as phosphorescence. I already gave the formula. Zinc sulfide is phosphorescence. So, under all these conditions, he observed, Thomson, some rays are moving from the direction of cathode to the direction of anode, and he named these rays as cathode rays. And what is the charge on cathode rays? Their electrons we already know, now we know, but Thomson, does he know? No. How does he confirm? He placed one more electric field. He placed one more electric field in the direction of the cathode rays. Now, cathode rays, students, you all know, like charges repel with each other, unlike charges attract with each other. Now, cathode rays bend, definitely they will bend, but they will bend towards which terminal? Positive terminal or negative terminal? These cathode rays bend towards positive terminal. This confirms This confirms which particles bend towards positive? Negative will bend towards positive, sir. No. This confirms cathode rays are negatively charged particles. Cathode rays are negatively charged particles, and they are being called as electrons, were named by Stoney, called as electrons. So this is the whole experiment about the discovery of electrons, and that's how electrons were discovered. Students, answer, are these subatomic particles electrons? Are they discovered just by seeing them? Can we see them with our naked eye? No. By analyzing the properties, these discoveries were done. Understood? Got the clarity about this electron, students? So we'll discuss some of the properties of these electrons. Electrons are also called as cathode rays. Next. So cathode rays travel in straight lines. Yes or no? Cathode rays travel in straight lines. What is the proof? If you place any object here, it will cast a shadow. Look at here. A metal cross is given. You can observe the shadow. What does it mean? They're moving in that straight direction. So cathode rays moves in straight lines from which direction to which direction? From the direction of cathode towards the direction of anode. Sir, why they're moving towards anode? Anode, what is the charge on anode? Positive. Positive, negative attract with each other. Yes or no? So these rays moves towards anode, straight line from cathode to the anode direction. So next, effect of electric field. Effect of electric field. That means cathode rays in the presence of electric field, students. We already discussed about this point. They bend towards which terminal? Positive or negative? They bend towards positive terminal. That means cathode rays are negatively charged particles. Yes or no? Cathode rays are negatively charged particles. This proves cathode rays have negative charge. They are called as electrons. Next, effect of magnetic field. You can see magnetic field has poles, north pole and south pole. The direction of these cathode rays in the presence of magnetic field is same as like expected for the negatively charged particles. That means they are behaving like negatively charged particles. This proves electrons are negatively charged. Yes or no? Look at the fluorescence screen is also observed. Why? Just to observe the deflection, deviation, that's it. Next, cathode rays consist of material particles. That means if a wheel is placed, the paddle wheel is placed, you can see light paddle wheel is placed in the direction of these cathode rays. These cathode rays can move this wheel. This wheel can be moved. This proves that cathode rays are material particles. When they are material particles, when they hit to this wheel, yes or no, they can rotate this wheel. Which wave can rotate the wheel? No. Wave can easily pass through. Yes or no? So this proves cathode rays are material particles also. So what is the charge on electron? This is the charge on electron, students. It is minus 1.602 into 10 to the power of minus 19 coulombs, or in terms of electrostatic units also minus 4.8 into 10 to the power of minus 10 electrostatic units. This charge of an electron is the smallest negative charge carried by any particle known. So this charge is taken as 1 unit negative charge. So that's why we are calling the charge on electron is how much? Every time are we saying in coulombs? Every time are we saying in ESU, electrostatic units? No. Simply we are saying -1. That is the charge which is carried by any particle, the smallest negative charge. So in general it is been called as -1 charge, negative charge. Next, the mass of an electron. These electrons are very light particles, students. The mass of electron is about 1/1837 times smaller than the mass of hydrogen atom. So actual mass of electron is, this is the mass, 9.11 into 10 to the power of minus 28 grams. The mass of electron is negligibly small. So an atom is made up of 3 subatomic particles, students: electrons, protons and neutrons. Yes or no? Electrons, protons and neutrons. In all these 3 subatomic particles, electrons mass is very negligible, very small. You can see it is almost 1/1837 times smaller than that of hydrogen atom. Hydrogen atom contains a proton and electron. That means electron is 1837 times smaller than proton's mass. Yes or no? Protons is heavier mass, neutrons also heavier mass, but electrons mass is very smaller. So these are the charges and masses of electrons. Next, charge to mass ratio of electrons. This is also called as specific charge of electron. The charge to mass ratio of a particle is known as specific charge, or E/m of that particle. The charge to mass ratio of an electron is said to be 1.76 into 10 to the power of 11 coulombs per kg, and conversion to grams is also given, students. Charge to mass ratio per per charge, per mass, what is a charge. So this E by M ratio is taken for electrons and protons also. E simply called as E by M ratio. E indicates charge, M indicates mass. Got the clarity? E by M ratio or charge to mass ratio. This is the value. Next, discovery of protons. Electrons were discovered by Thomson, then protons were discovered by the scientist Goldstein. Students, protons were discovered by the scientist Goldstein. In the same experiment, you can see, same glass tube, high voltage, low pressure, vacuum pump, cathode, anode, same gas, hydrogen gas or helium gas. So same, everything, all the setup is same. But this time students, phosphorescence material is coated on the back side of cathode. Yes or no? Right? Why? Because you already in the previous discussion, once if the hydrogen atom is dissociated, once if electrons were knocked out of the atom, then which particles will remain? Protons and electrons separately. Electrons were already discovered. That means what are the remaining particles are there? Definitely in the glass tube. Protons are there. Yes or no? Protons move towards which electrode? Positive electrode or negative electrode? Negative electrode, which is cathode. So they are moving towards negative electrode. So it's a simple change, simple discovery, the same setup. Then why one more scientist? Why not Thomson did the same? Why? Because students, Thomson have tried, but he didn't observe these anode rays. Why? Because one change is expected in this experiment, which is not done by the scientist Thomson, which is done by the Goldstein. So that's why he claimed the discovery of protons. What is that change? You can see this cathode. This cathode with holes, you can see the holes inside the cathode. This cathode with holes is called as perforated cathode. That is a change which is done by the Goldstein. Sir, why he made the holes on cathode? Why? Because students, like Thomson, he made any holes on the anode for the discovery of electrons? No. But why holes were needed here? Why? Because I already have said, electrons are the lighter particle. There is a small space. Who can fit easily? Who can pass easily? The slim person or the non-slim person? The slim person. Yes or no? So electrons are the lightest particles. They can easily penetrate through the electrode. But protons are the heaviest particles. Can they penetrate through the electrode? No. Definitely holes were needed. Yes or no? That's why if holes were made, then what will happen? They passed through the holes and they hit the phosphorescence material. That's why holes were needed. Why? Protons are the heaviest particles. They cannot easily penetrate through the electrode. Holes were needed. So this cathode with holes is called as perforated cathode. Major change from discovery of cathode rays to the discovery of anode rays is perforated cathode. Why? Protons are heaviest particles. Remaining everything, all are same. Even the properties also same. High voltage condition, low pressure condition, all the reasons are same. Properties are also same but opposite simply. Look at the properties of anode rays. Straight line propagation. Like cathode rays, anode rays are also travel in straight lines. From which direction to which direction? From anode to cathode. Yes or no? These rays are called as anode rays. And one more thing students, to confirm the charge on these anode rays, he placed one electric field, positive terminal and negative terminal. Answer, these rays bend towards which terminal? Positive or negative? They bend towards negative terminal, which confirms these rays are positively charged particles. Later on they are called as protons. Understood? Simple discoveries. So they also travel in straight line from anode to cathode. Mechanical motion and the heating effect. That means if you same wheel is placed, it can rotate the wheel. So and as it can also show the heating effect because of the high energetic particles. They show the heating effect also. Effect of electric and magnetic field. Just now I have said. So in the presence of electric field, they are bent towards a negative terminal. Confirms anode rays are positively charged particles called as protons. In the presence of magnetic field, the deflection of these anode rays are same like positively charged particle. That means it proves protons are positive charge. Next, charge of proton. Charge of proton is same like electron but opposite. Yes sir, electrons are negative, protons are positive. The charge on proton is equal to that of electron, but it is a positive charge. The charge of a proton in coulombs or ESU students, this charge of proton is the smallest positive charge carried by any particle. So in general it is taken as, for an electron it is taken as -1, for proton it is taken as +1. And the mass of proton is, found to be identical to that of hydrogen atom, which has 1 atomic mass unit, 1 AMU, which is 1.672 into 10 to the power of minus 24 grams, or in terms of AMU is also given. A proton is about 1837 times heavier than that of electron. Protons are the heaviest particles. That's what the point, that's what the reason which we discussed in the case of perforated cathode. Yes or no? So they have heavy mass, students, these protons. Next, charge to mass ratio. Unlike cathode rays, the E/M ratio of positive charge on anode rays depends upon the nature of the gas taken in the tube. The charge to mass ratio of the particles in the anode rays is considerably smaller than that of electrons. The reason is, students, the charge to mass ratio for electron is same every time, but for proton it is not same. The reason is, once electrons were knocked out, it behaves like independent particles. Sir, no, hydrogen atom, lithium, beryllium, boron, take any element. Once electron were knocked out, electron has a negative charge, it has its mass, right? But are we removing protons? No. Hydrogen contains 1 proton, yes or no? Helium contains 2 protons, along with 2 protons, 2 neutrons are also there. Lithium contains 3 protons, what is the charge? Plus 3. Beryllium contains 4 protons, what is the charge? Plus 4. But electron everywhere is minus 1, right, student? That's why E/M ratio for cathode rays is always same. But for anode rays, it is not same. Sir, why it is not same? For proton is also plus 1, but they're combined. If 2 protons combined, what is the charge? Plus 2. What is the mass? 2 mass. Instead, there is neutrons also which provides the mass. Yes or no? That's why E/M ratio of anode rays is different for different gases. Discovery of neutrons, students. Discovery of neutrons is done by the scientist James Chadwick, and in a nuclear reaction, he discovered these neutrons. He is doing one nuclear, it is an accidental discovery, students. He is performing a nuclear reaction between beryllium and helium. He is bombarding this beryllium with helium, and he got carbon and a neutron. So it is an accidental discovery. Look at here, beryllium atomic number 4, mass number 9, helium atomic number 2, mass number 4. I already have said nuclear reactions takes place by the nucleus. That means protons can combine. Yes or no? 4 protons here, 2 protons here. 4 plus 2, how much? The new element contains how many protons? 6 protons. What is the element with 6 protons? The element is carbon. The element is carbon. So 2 plus 4 is 6. 9 plus 4 is how much? 13. But here, look at here, only 12. What about the extra? The extra particle is neutron. He got in this nuclear reaction. And when he analyzed this neutron, he confirmed these neutrons are chargeless. That means they are not bending towards any positive or negative terminal, and they have mass almost same like mass of proton, little bit heavier. Neutron is little bit heavier. This is a discovery of neutrons by James Chadwick. Look at the properties. The mass of neutron is slightly more than that of proton, which is 1.674. In the case of proton, it is 1.672. Yes or no? That's the only difference. Into 10 to the power of minus 24 grams. Electrically, a neutron is neutral, that is, it has no charge, right? Neutrons are no charge, chargeless. It is in a particle element, the number of neutrons in the nucleus in its atom may vary. So this point also. Protons and electrons are always equal in number in atoms, yes or no? But what about protons and neutrons? Are they equal? No. Remember, they can be equal sometimes, they cannot be equal also. It depends upon the repulsions between protons and the nucleus for different elements. For example, carbon, 6 protons, 6 neutrons. Oxygen, 8 protons, 8 neutrons. Sodium, 11 protons, 12 neutrons are there. So neutron number cannot be, may or may not equal. So next, to summarize electrons, protons and neutrons, this is a charge which gives the charges, relative charges, mass in kilograms, AMU and approximate mass. But before going to discuss about this chart, let us define an electron, students. With all this information, can you define an electron? Yes. What is the definition? An electron is a subatomic particle with a negative charge and having a mass of how much in terms of AMU? Generalized 0 AMU. So an electron's mass is very, very negligible. Define proton. A proton is a subatomic particle with a positive charge and having a mass of 1 AMU. How can you define neutron? A neutron is a subatomic particle with no charge and having a mass of 1 AMU. These are the definitions of electrons, protons and neutrons. We already discussed about, these are the symbols which we indicate electrons. E negative in general, E negative, protons P positive, neutrons N0. No charge, no. So these are the charges, relative charges, mass in kg, AMU, and in terms of, these are main relative charges and in terms of AMU, you have to remember. So student, that's all the discoveries of subatomic particles. Very important discussion, all the reasons. I hope you got the clarity. In the coming video, we'll discuss about how these particles are arranged. So different atomic models we have, and we'll continue in that video. Thank you, students.